Iraq Kwan. Have you? Well, maybe not, right? I came here 2020 January. Um, I was in Caroline University for 10 years before I came here. So I'm not new, kind of new, not new, okay? So I know this area, and what else? Okay. Okay, my background is my undergraduate was electrical engineering, focusing on digital wireless communication, which I don't like. And then my master's degree was from artificial intelligence, natural language processing, not like vision based. Back then, before this deep learning was popular, become popular, different approach. It's pretty much like a syntax based natural language processing. So, you did ask him passwords or something, I don't know why. Okay. And then that was like 1992, 1994. And then I worked for companies for 10 years before I decided, okay, let's get my PhD. I want to change my career. So I came here, not here, but the United States, 2004. That was 2004 until 2009. I was in Texas. I got computer engineering degree there. My major was computational neuroscience. It's like a brain function for computer. We don't like. I don't like dissect, but I see mouse brain. And then I, started my teaching career at Flint, Caroline University. I was happy there. I got tenured and everything was good, but I just want to do more research. I was able to do some level of research, but I want to do some more in-depth research. That's my major reason I changed my school from Caroline to here. A little bit disappointed now, but at least, yeah, I can manage. So yeah, so I just started here as like I was associate professor at Caroline University, but now downgrade to assistant professor again, and I was really excited when I came here. Some of you may know it. And then like 2020, that was 2020, right? So March, early March, maybe, hey, go back to your home. And then due to the COVID-19, I closed the campus, and shoot, I just came and I just want to see people. And I want to see you guys. I want to see students, and I want to, like, especially ISC, I'm really interested in like body competition, so I want to meet you guys. I want to do something with you guys, but shoot, my hands are tied for almost 2 years. And really, to me, it's really hard to like start up. I mean, especially everything is like established here, and then like, hey, just for 2 years or back then, nobody knows how long this will be. Right? So maybe we expected like a few months or 6 months or 1 year. Hey, get back home and like, remote doing stuff. That can be okay for other professors established in the labs and people. But to me, it was very challenging. I just came and start making connection and then, hey, go ahead. So anyway, yeah, that's, since I need some time to make this working, let me try. Maybe not. Maybe I need to restart. Yeah. Okay, let me restart. And can I borrow your computer? Yeah. Fast. Oh. Okay. Thank you so much.
I think the top of the backpack's in the
That is my main screen. External between mirror, no, I don't see anything. Okay, that's that's short bio. Oh yeah, I'm currently ECE faculty and robotic engineering faculty. Inside the ECE, ECE department has CEERE, so I'm in robotics. What else? Okay, that's pretty much it. So I want to just show you what I did last like 10 years. Yeah, first one is autonomous vehicle. So open source car architecture for research and education, which is called Pascal. I named it just like it, and this is based on ROS1, and we developed a vehicle model. Used to be GM Chevy Bolt, electric car. So when I came here, I switched from GM Bolt to Ford Fusion, because I wanted to buy this Ford Fusion real car. because I want to integrate, basically I want to integrate this simulated environment with the real world environment so that we can test something, we can develop something inside this environment and then deploy that into the real vehicle and do something. I don't have the vehicle yet. Money is assigned, but somehow, again, similar situation. So what I'm showing here is I already trained this a neural network, which is called end-to-end, E2E or end-to-end, or behavior cloning. You guys know the behavior cloning, right? Or E2E, right? No, not really? Not really? You guys? Okay. Then I'm gonna show you quickly. Let me show you I have some material for Ford. Ford AI something, I don't remember. Let's see. Or E2E or end-to-end, meaning this is a conventional approach for self-driving. We collect data through the sensors and try to extract important features. That is called feature engineering, which means like engineers try to get, okay, what are important features to do something, okay? And then like get the parameters for actuation, and then apply to a driving controller. This is a traditional or conventional approach. Behavior cloning means this job, feature extraction, parameter for actuation, that's so complex and so delicate, like with different lighting condition, different weather condition, different background color, and just try to extract like simple lanes. That's not even easy, right? So instead of doing that by an engineer, we can let a neural network find what are important features, okay? I'm gonna give you enough data. So we give data, and then this end-to-end behavior cloning system, which is basically a neural network system, will find that association, input image, and then steering angle, input image, steering angle. We don't even need to say which one is important. We just give an input image and then, hey, from human driver did this when they see this, okay? And then, hey, find out. That is called end-to-end or behavior cloning. Since we are cloning a human behavior, so that's why we say behavior cloning. Or end-to-end means we don't need to worry about in between. One end to the other end, and two end. Nothing in between, okay? Just believe the data. So why behavior cloning? Again, I said same thing. Okay. I want to show you the short history. Alvin, 1989. Very simple, shallow, thin network, traditional neural network. Only 30 by 32 video images back then. This is huge data. But with this simple Alvin system, was able to
Todd
drive.
Yoakum is behind the wheel of this Army ambulance, but the CMU graduate student isn't driving. A computer is. The machine watches the road through a video camera perched above the windshield and steers the vehicle itself.
We've had it up to 70 miles an hour, and it's driven autonomously for over 90 miles straight without the human ever touching the wheel.
That's right. This robotic vehicle is driven to Erie and back on I-79. It's the result of 8 years of military research and
So when you have time, you can search this video. That's what I want to show you here is what I'm doing here, or what we are doing here, is not new. It's been like how many years? Like, almost 30 years, right? Fundamentals are basically same. 89 is about time CNN was developed. So they didn't use CNN, convolutional neural network, back here. I mean, back then, again, the image size is small. And the convolutional neural network developer, Raccoon, is now in Facebook, I think, Facebook AI head. He was in Toronto under the Jeffrey Hinton, who developed backpropagation algorithm to train a neural network. Okay? Those guys are like pioneers in this neural network area. Anyway, even without using convolutional neural network with a shallow 1898, they were able to drive the vehicle. So point is still like I do. And 2003, Dave, DARPA, autonomous vehicle experiment, small RC style vehicle. This is the first time ever convolutional neural network was used for any kind of vehicular system. Very simple, only 6 layers, 225,000 sample images, driven 3,200 runs, was 2003. And 2016, after 10 years later, neural network architecture, which is called PilotNet. This is from NVIDIA. The hardware was NVIDIA PX2. This is a GPU computer. Pretty much same, like the Alvin, 1989.
Holy cow. Whoa. Whoops. Wrong way.
Crazy, right? They can do this in a simulation environment. After 3,000 miles later, it's much nicer. So as you can see in the right side, this is basically same as RV. Give this input and then through the get through the convolutional neural network and then try to predict steering angle. It's basically find the association between input image and then steering angle. That's everything. Okay.
Yes, to clarify, is it only the image, or are they feeding other sensor data in this one?
No, this is image only. The PilotNet, that's only image only. This paper is not peer reviewed, but in the do you know guys the archive, RX archive? No, maybe not. Okay, maybe, but that's for the graduate student guys. managed by Cornell. This is a place where anybody can post anything. No need to be reviewed. So like Facebook, Google, they don't need to like publish in a like transactions which requires like more than a year or 2 years review process. When they got something they wanna publish as early as possible, then they usually put it here. And then archive is Cornell, they don't claim anything. So even though I upload anything here, and then later if I find a journal or conference, I can publish it because they don't claim anything. They just wanna manage this. Anybody who wants to, publish their idea, so that later they claim, oh, that's my idea. Okay. Anyway, the paper from the NVIDIA PilotNet you can find here. But later, you can find similar paper in transactions. Okay. Yeah, that's the end-to-end. You got it, right? Okay. So what I did here was like, okay, since I don't have a car, I want to do the similar thing with a simulated vehicle. So I asked my student, hey, drive this vehicle for many, many hours, and then use the data, train a neural network, similar to the PilotNet, but not identical. And then here it's like too small, but we also create a driver which use the neural network, predicted steering angle, and apply that steering angle to the vehicle so that the vehicle can drive. That's the earlier, and then we have another platform. This is the Pixoc. Did you guys know Pixoc? No, maybe PX4, Pixoc. This is a controller for drones. And they also support the simulated environment. And since this is controller for drones, why not for robots? So also they support the ground vehicles or underwater vehicles. So this one was earlier trial to use the Pixoc. This is not like the Oscar platform that I developed. This is Pixoc. So we can drive, collect data.
Is
And
that just raw point clouds they're using? Is that just raw point clouds? Right there in that one?
This
And
one?
the RViz? Were you doing any filtering? For the
No, we don't filter anything. This is just the raw data, and then we visualize LiDAR data. And we don't, see, this is the starting point and this is the point. I just drive, okay. I was not a good driver, so I just drive this way, that way. And if it can collect data, I just test it with this particular model. But anyway, these are all done with ROS1. So I'm so excited to see ROS2. And a lot of different research topics that I'm doing, but I just want to show you. This can be maybe robotics related. I converted this kids ride-on car, basically the electric remote control car. We converted this to drive wire, and then again same thing, collect data, and then train neural network, and let the vehicle drive. So that was this is autonomous vehicle in a hallway using a 2D LiDAR and camera. Right, and back, right, and you're gonna turn left. There is no like localization, so it's just purely rely on visual and then LiDAR input. That's why we put this. Otherwise, there's no way to find out which way I should go. Okay. Yeah. Anyway, this is something what I have been doing. So yes, that's me. I'm doing this, but since my background is computational neuroscience, I wanna utilize brain function, how brains are working for a particular task. So I want to integrate the brain function to this autonomous vehicle so that the autonomous vehicle can be more smart, more intelligent. Okay, so that's like my big research topic area. Okay, any questions? Okay, cool. Are you guys all CE, robotics? Mechanical?
We're CIS.
CIS, okay. How about CIS?
Robotics.
Robotics.
Software engineering.
Software engineering, okay. Pretty much CIS, okay.
It's just different electives, basically.
Yeah.
This is off the topic, but we should combine CIS and EC. My area, as you can see, my background again, electrical engineering and robotics, but most of the topics that I'm doing, I absolutely need CIS students and CIS, faculty members. I should be able to work with CIS guys, but here, EE, okay, CE, maybe. Okay, anyway, so my plan for ROS2 workshop is, again, as I said, we don't have any English written material for ROS2. There are some for ROS1, but not for ROS2 many. I mean, obviously, if we can go to ROS2 wiki, like a standard, everything here we can follow, but obviously it's not easy to follow for especially beginners. So that I just wanna give you like a stepping stone. So what I'm gonna use is this material. Don't worry, okay? Okay. I will use this as a reference. I am gonna use like this way. I can create a material for later, for someone else later. But I want you guys, I mean, I'd like to use this material for you guys. I mean, I don't want to repeat every like line by line here, but for example, okay, let's say, for example, the first topic, which is what is ROS? Okay, what's ROS2? Why we have ROS2? So, I mean, you guys already know what ROS is, and then why. It's only like a 10 years old, and now it's 12, right? Before, like a 2010, when people wanted to have any kind of robotic system, they pretty much started from scratch. When they need a camera, and they need to find out like a device driver and how we interact, and then when they need a vehicular platform or legged robot, they need to find like motors and mechanics and everything, and then try to make, and then like how to interface, and okay, I have a camera and I have a LiDAR, okay, what can I do? You gotta write a code, it can be like a C++ or C, and then analyze data and how to somehow combine. There are lots of different ways and lots of things to deal with. But after 2010, ROS1 was introduced. Things are much easier now, but it's kind of like steep learning curve. If you want to feel like cozy ROS environment, you have to climb, right? And then once you climb up and jump into the ROS2, everything is really nice. Okay, so pretty much straightforward. There are lots of tools provided. This visualization tool and then interface tool as well. And ROS2, the main downside of ROS1 was the main framework, which uses ROS core. You gotta have ROS core. Everything must get to the ROS core. So ROS core somehow tempered or going crazy, all systems are they're going bad. So that is not good for secure robotic systems, right? If something is wrong, one system, then that's it. You cannot do anything if ROS core crashes. So ROS2 is more like a distributed now. ROS core is not here anymore, right? So the left is ROS1 and right is ROS2. ROS1, as you can see, application layer, middleware layer, OS layer, Linux only. Experimental platform was like a Mac or Raspberry Pi, Raspbian, but they are not official. Only official platform was Linux for ROS1. And then there's a master here, that means ROS core. And then you can put in applications here. ROS2, no ROS core or master anymore. And we have a additional new component, DDS. And then also it started supporting Windows, Mac, and Altos as well. Okay, so these are some environments that this workshop will use. Simple indoor environment and some cones and walls and they have a robot, 3D printed robot. Since this is like our workshop, we don't actually build this one. I just want to show you. Also, we have a other platform, but like as I showed you earlier, like the vehicle platform or the robotic platform can be built inside for simulation environment, and then do whatever we want. And we can deploy the developed algorithms to real vehicle. Yeah, that's a quick introduction for ROS2. I didn't know before I started learning ROS2 the difference between ROS1 and 2. I don't see much, difference. That's pretty much the same. Core concepts are same, except the ROS core part. So, as a user, nothing much different and nothing special was 1 and 2. It's pretty much the same. Okay. And then next week, I want you guys do this ROS2 Foxy installation on Linux 20, especially you guys already have, right? So especially the beginners. I want you guys have like laptops, but those like Linux laptops. Okay, cool. Have you installed already? Good. ROS2, okay. Foxy, okay, cool. You guys already?
Not yet.
Not yet, okay. We can, this is 6:54. I gotta go. So I gotta stop right here, but next week we will start from here. We have multiple options like multi-boot, dual boot, or virtual machine, or separate machine. But I strongly recommend separate machine is the best choice. But if you don't have like multiple PCs or laptops, at least dual boot is the next option. VirtualBox is like, it's easier to manage, but it's like slow. So yeah, and then how about like a Linux experience? Do you guys know how? Okay.
I mean,
I've never used Linux
downloaded it, I
before.
have it, but I haven't used it before,
Okay.
so.
Okay, then let's do this. I'm gonna use this material as a base, and then for example, okay, let's install Foxy, and then you gotta use like some commands, right? And then you have to understand at least that like a data directory structure and how to navigate. And obviously you could use like a graphical user interface too, but much best and much better to use command line and navigate and identify a file and then run it, those things, okay? So, as we see something that I need to explain, then I will open like Linux tutorial and explain how to use it and concepts, okay? That's cool. Yeah, that's it for today.